practice writing equations of hyperbolas when we're given some information about the hyperbola. And we're going to start with this. We'll do this problem. Suppose we know that the vertices of the hyperbola are at plus or minus 4 and the foci, plus or minus 4, 0, so on the x-axis, and the foci are at plus or minus 5, 0. I find it easier to think the process through if I draw a picture, just to give myself a sense of what's going on. So here's my hyperbola. My x-intercepts are, they are the x-intercepts. They're also the vertices. They're at 4. I'll put 4 right here and negative 4 right here. And notice that that means that the center of this hyperbola will be at the origin. So let's jot that down. The center is at 0, 0. Whoops, I'm writing on the directions here. Let me move the directions out of the way. And we know we're looking for the equation of the circle. The center, did I say the equation of the circle? The equation of the hyperbola. The center is at 0, 0. Now the foci are inside the branches of the hyperbola, and they are at 5, 0, and negative 5, 0. And we know now that the hyperbola is going to open right and left. We had these as vertices, so we knew it at that point. And we just also know that the foci are always inside the branches of the hyperbola. So I just have a rough sketch that looks like this. And I absolutely don't know how wide or narrow the hyperbola is, but it still helps me think through the process of coming up with the equation. So let's jot down what we know. Since the hyperbola opens right and left, I know that the expression is going to start with the x squared over a squared, and then it's going to be y squared over b squared equals 1. And because the center is 0, 0, I know that I'm just going to have x squared and y squared in the numerator. Now let's look at our picture. We know that the distance from the center to the vertex is always a. So for this problem, a is equal to 4. And that means a squared is equal to 16. We know that the distance from center to focus is c. So for this problem, c equals 5, or c squared equals 25. And the relationship between a's, b's, and c's in a hyperbola we know is always a squared plus b squared equals c squared. So if we substitute in our a squared and our c squared, we'll be able to find b squared and we'll have our equation. We already know the a squared, we just need this b squared. So let's substitute in those values. So we have 16 for a squared, and we have 25 for c squared. So b squared must equal 9. So when we substitute in our a squared and our b squared, our equation becomes x squared over 16. There's our a squared. Minus y squared over 9. Equals 1. And we have the equation in standard form for the hyperbola that has vertices at plus or minus 4, 0 and foci at plus or minus 5, 0. Let's do another one. For this problem, we'll have the vertices at 2, 5, and 10, 5. And we're going to have the equation pass through the point 13, 7. So a little bit different. But let's draw a picture of what's happening for this one. So our vertices are at 2, 5, and 10, 5. let's see, 2, 5. We'll put 2 here, 4, 6, 8, 10, about here. And we'll just put 5 right here. So the vertices are at 2, 5, and 10, 5. So again, I can tell we have a hyperbola that opens right and left. So I'm thinking about the standard form of the hyperbola being something that looks like this. X squared, but instead of just an x squared, how about x minus h squared over a squared minus y minus k squared over b squared equals 1. And I put in this hk because we know that the center is not the origin this time. But let's continue. Where is the center? The center is right in dead center in between 2 and 10. You can average 2 and 10 and determine that the value right here would be at 6. Right? It's the midpoint of the line segment that joins 2, 5 and 10, 5. So my center is at 6, 5. So we can put that into the equation. Why don't we do that? So we have x minus 6 squared over a squared minus y minus 5 squared over b squared equals 1. Now we haven't used the fact that the graph passes through the point 13, 7. Let me just draw that, what that means. Let's see, 13, we'll say that's about right here. 7 is about right here maybe. So it's just saying that we know the graph will pass through that point. So maybe the hyperbola looks like this. And it would have the same shape over here. Oh, a little too pointy there. We know that the hyperbola is a smooth curve. And it passes through this point 13, 7. But notice we are still shy of an a squared and a b squared. Let me come back to the picture. We know the distance from center to vertex is a. So on our picture, let's see, the distance from 6, 5 to 10, 5 is 4. So a is equal to 4, and that means a squared is equal to 16. Let's pop that into our equation. So we have x minus 6 squared over 16 minus y minus 5 squared over b squared equals 1. So the only thing we don't know is what b squared is. Now I don't know b, I don't know c, all I have is a squared. So I can't use the relationship between a's, b's, and c's to find this. What I can use is the fact that the point 13, 7 lies on the curve to determine b squared. Since 13, 7 lies on the curve, the point 13, 7 must make this equation true. So let's pop 13, 7 into this equation. So we have 13 minus 6 squared over 16 minus, now 7 goes in for the y value, and now we have an equation with b squared, our only unknown. So let's do some arithmetic here. Let's see, 13 minus 6 is 7. 7 squared is 49. So we have 49 over 16 minus 7 minus 5 is 2. 2 squared is 4. So we have 4 over b squared equals 1. We have a couple of different ways to solve this equation. You could subtract 49/16, or you could multiply both sides by 16b squared, which is what I'll do. I'm going to multiply both sides by 16b squared. and just eliminate the denominators. If I do that, I have 49 b squared minus, the b squareds cancel here, 64 equals 16b squared. Let's see, I'm going to subtract this 16b squared, bring it to the left side, and I'm going to add 64 and bring it to the right side. So that means I would have 33b squared equals 64. So b squared equals 64 33rds. There is nothing that says that the b squared and the a squared need to be integers at all. So let's see, here's our equation. Let me come over here. This is my only blank part of the page. We're substituting this in for our b squared. So the standard form for the equation of this hyperbola is x minus 6 squared over 16 minus y minus 5 squared over 64 33rds equals 1. Now, if you'd prefer to see that with a decimal, we could just grab our calculator. So 64 divided by 33 is about 1.94. So we have x minus 6 squared over 16 minus y minus 5 squared over about 1.94 equals 1. But I actually would probably leave the answer this way. That's the exact equation that represents this. This is pretty close, and some people just prefer to see the denominator written as a decimal, but either way. Let's do one more. Let's do this one. Vertices are at -1, 1 and -1, 3, and the foci are at -1, -2, and -1, 6. Again, I'm going to draw a picture because it helps me think it through. So let's start with the vertices. -1, 1. So let's see, we'll put -1 here, 1. There's one vertex, and -1, 3. Here's 3. So immediately we know that the hyperbola this time opens up and down. Again, I don't know how wide or narrow it is, but here's my little rough sketch because it helps me think it through. So this time I know my equation will look like this, starting with the y squared first. So it's y minus k squared over a squared. Remember, the a squared is the denominator of that first expression, minus x minus h squared over b squared equals 1. So let's find center so we can pop that in. Let's see, our center is right in between -1, 1 and -1, 3. That would put it right here at -1, 2. So the center is at -1, 2. Let's put that into our equation. So we have y minus the y coordinate over a squared minus x minus the x coordinate. So x minus -1 becomes x plus 1. Now let's come back and see what we know from our picture. Oh, and we haven't even put the foci on yet. But let's first look at for A. I know A is the distance from center to vertex. And I've drawn it pretty small, but notice the distance from -1, 2 to -1, 3 is 1. So A is 1, and that means A squared is also 1. Now let's put the foci in. Let's see, where were they? -1, -2, oh, down here. And -1, +6 up here. 3, 4, 5, 6 up here. So we can look at the C value or determine the C value if we see the distance from center to focus. So this one is up here at 6. This one is down here at -2. Remember, our Y value at center is at 2. So from 2 up to 6 is 4 units. And 2 down to -2 is 4 units. I was just confirming that I have that correct. So my C value is going to be 4. So C equals 4. And that means C squared is 16. We know the relationship between A's, B's, and C's is A squared plus B squared equals C squared. So I have A squared is 1, B squared is what I'm trying to find, and C squared is 16. So my B squared is 15. And now we can put both of these pieces into my equation. So A squared is 1. So I have Y minus 2 squared over 1, but I don't really need to write the over 1. That's implied since I'm not going to write it over anything. Minus X plus 1 squared over B squared equals 1. And now we have the equation of the hyperbola that has these vertices and these foci. Now I hope you can go practice finding equations of hyperbolas.